Hey guys, so I've been messing around with the Flip Fluid add-on and geometry nodes, and I wanted to teach and share what I've found, I guess. Now, you might be asking why I'm not using mantaflow. Why am I using a paid add-on like Flip Fluids? And that's 'cause, well, mantaflow is a little bit jank right now, at least. So I have this example in Blender 3.0 set up where, you know, ball is thrown and turns into fluid. But as you saw there, instead of carrying the velocity of the ball, it just goes straight down. Like the instance it brings up, it doesn't remember any of the velocity that the ball has besides the fluid itself, the fluid emitter having initial velocity on it. So I'm not sure how to really remedy that, but it's one of mantaflow's weaknesses where it's not easy to make it follow a geometry or be thrown per se. It's more like you set the fluid up and it falls or it's there already. And yeah, I know you can mess with the initial XYZ to make it kind of look like it's following, but it takes a lot of finagling and working. So now that that's out of the way, okay. Now why am I in Blender 2.93? Well, that's because currently, as of recording, Flip Fluids doesn't want to work on Blender 3.0. I do not know why, but it just it doesn't want to bring up the it doesn't want to bake. It has a baking issue, and I'm hoping they fix that soon. But for now, we're gonna have to do a workaround. So we want to use the switch function of the switch node in Blender 3.0, but that's not available in 2.93. So what we have to do is, well, we have to build our simulation in 2.93 and bring it over to uh the 3.0. So building it, first add the domain, and then it's gonna be the ground, gonna be body passive, a throw, previous example, a ball. So I want ball here to catch the ball. It's also a passive. Add a U, and we are gonna frame location here and then couple frames. Ball here, location. And we're gonna give it a rigid body active. Frame before it, animation off. Then got a ball thrown. It's not the hardest ball thrown, but it's a ball thrown. So we want that on impact, it turns into. So first, what we have to do? Well, we have to bake the rigid body. So go here to our scene properties. Go to rigid body world cache. Let's lower this down to 100 frames since I don't really want that much. Bake it. The light. It's a simple scene. Now you might think, okay, that's it. Now we get out of fluidus. No, we have to bake the keyframes. So in case you didn't notice, I clicked on the ball and went rigid body, baked the keyframes, and pretty much just press OK, and now the ball has keyframes. It no longer has a rigid body system. This is all keyframe motion. What does this mean? Well, it means we could remove the rigid body off of the planes. We don't need that anymore. And it also means we can now duplicate the ball, and it has a ball that follows the same motion. Now, our first ball, we're going to rename to rigid body dynamic. That's the main ball, the first ball you're going to see. And then the second one is the fluid emitter, so we're going to name it. Now, we want to switch the fluid ball into the fluid. Now, important that we also add obstacles here so that we have to bounce off of. But now In the fluid object, we need to add object velocity to meaning it'll actually calculate the velocity of the ball being of the movement and put that into the end. We also for fluids, we also need to export animated mesh. Back down here in the domain, we need to find where our impact is. We don't want to simulate anything before that because we don't want the liquid to exist before the impact. So, well, a couple frames before impact will be okay, just so we can get that velocity in there. So frame 18 looks nice. We need to go into our bake setting, custom frame, set it to 18, and frame 120. And now the fluid will only exist from frame 18 to 120. And of course, we have to go into our cache, find our cache. I already have one up. Go there. And I'm not really going to worry too much about resolution, but what I am going to worry about is the surface. We want to turn off surface tension and sheeting so it has a bit of more water effect and not so much individual chaotic particles. And now we hit bake. And now our baking is done, and we press play, we see we have a fluid simulation. Now, normally here we would then go into geometry nodes and add the switch function, but this is Blender 2.93, and the switch node is not in this version. So what do? Well, we have to export our fluid sim as an alembic. So here we go to File, Export, Alembic. We look for the correct folder. I'm gonna add it here. Let's add a new folder, call it. And we're gonna save it here. We're gonna go to make sure this is on selected objects so that any selected object in our scene is the one exported, nothing else. We're not gonna worry too much about normal. I was told to export face set, no export arrow particles. I believe we have to turn off normals, but I could be wrong on that. Way, and then we export the alembic. It'll write the alembic to memory as we go, Then go into Blender 3.0, import an alembic, find that alembic, import it, and now we have our alembic. Now, scale is a bit wonky. I don't know why this happens. It seems that importing alembics is a little bit weird. So we'll fix the scale later to make it look same. Hopefully this is fixed soon so we could just do it all in one blend file. Now we want to grab our cubes and our rigid body ball. If we Control C this, copy the objects, go to another blend file and Control V, paste it into the scene. Now let's grab our fluid and scale it down. Now, here's where we want to kind of figure out where it should go. If it's there, because fluid does expand a little bit. That looks just about right. Okay. So now we have our rigid body, we have our fluid that appears, and now we could add the switching functions. So on our ball, we go to geometry node, add a new node network. Now, it's always good practice to move things into collections. So we're gonna call this fluid. everything that's fluid related into there. This is the scene. This is rigid body dynamics. Now this is a simple scene. You could obviously, the more complicated you go, the more things get wonky. So you have to figure things out on your own, and that's the beauty of stuff like this. It's a puzzle. So as before, we bring in a switch node, put the switch into the port so we could have access to it. And now we want a input collection info. Bring in the fluid. Now if we plug that in, set it to relative, we've successfully brought it in. Hide the original fluid. We have the instant fluid. Now all we need to do is animate this property. So we find where our frame is, our frame of contact, which should be frame 20. Animate that to the one before, and we have a switching. Now if we play this, the ball has just melted into a puddle of water. Now from here you can render it. You can add your materials. Obviously if you go to the ball, add a material, go into the shader network, and let's change it to red. Change the ball, but let's say you don't want to go into the fluid itself and change. You want to leave that out of it. So what you do is you add a new material into the ball. Call this fluid so we know what it is. Go into geometry nodes. Here we go into material assign, and we assign it fluid material. Now in shaders and shader nodes, when we change something here, change fluid material without changing the original, because we're assigning the material through geometry node, which I think is something nifty. You could also just assign the entire process through here instead of manually inputting it through here, but whichever is easier. You also have a selection here for vertex, so you can have your own vertex groups and put them here, or attributes, etc. But that's for someone with more ability than me. All right, so here we go again. There's some more stuff to show. So once again, we're still going to continue using flip fluid add-on. So let's create our domain here. Scale it up so we have a nice. Apply the scale. Always apply scales when you change stuff in object. Domain. Now we have our domain. Now, what I want to show you guys is how to make changes and interactions using geometry nodes along with fluids. So the first one that comes to mind is moving the fluid source itself. So say we have this UV sphere. Let's back here origins. We have it as a inflow, so it's constantly dropping in. So obviously we have it just up there. If we bake it now, set up our cache first, because I always like setting my cache manually. I don't like it when it saves it somewhere randomly. Also change the frame, so not that big. And as last time, surface tension heating. Now, if we bake this now, it's just going to be water going down until we tell it to stop, which we should do that. So on frame 30, I want it 31. I'll have it stop, and then the rest of the there. So that's our keyframe, whatever. So if we bake this now, it's just gonna be falling straight down, no changes, nothing special. So what we do is here, open a tab. Oh, I need to update it, and let's put in a node network. Now we want I want to move this through geometry node. So what I need is a transform node. Now I want to spin this specifically in a circle, and I want this to change over time, obviously. So I need to first take the translation because we want movement, not rotation or scale. So we want to separate the XYZ value. Now we're gonna need math in order to move this. So divide, make this sine, cosine. Not that. Move that both to y. Now connect up the values. Bottoms 1. And this will control the size, and this will control the intensity. Now, if we move our first value, nothing happens because I didn't connect anything to. All right, so the top node to X, bottom node to Y. Okay, now you can see how smart I really am. So from our top value rotates our sphere, and our second value offsets it from the center. So we want to have this constantly spinning, so we do a simple driver pound frame, and then what this will do is it will take every frame, so 1, 2, 3, 4, 5, 6, but we don't want it to move this fast. We want it to move slower. So we multiply it by 0.1. You could also divide it, but I'm not sure how that works, and I'm not that smart. And after that, we just scale it out, and we now have a spinning circle. Now this is something simple. If you want it to bob up and down, it's another set of math nodes, and then you connect it to the Z, but we're not going to do that right now. So we see that it is in fact, spinning around. Let's go into the domain. Well, first, we need to tell Flip Fluids that this is an animated mesh. So we need to export this animated mesh so that it could tell, okay, this is moving, we need to bake it out. So here if we hit bake, we have the animated mesh go first, and it starts baking our geometry. See, it's starting to follow that movement. Now the top part here is because it's outside of the actual domain, and I think there's a buffer because I'm using a low sample count. So it's a little bit weird, but you see it still works. You see that it's following the ball. Now stop this. Grab. Let's reset the bake so that way could add object velocity to inflow, and now the velocity is in effect. We bake it out again. Once we already baked out the mesh, if we're not gonna change it, we could just skip re-import, and that way next time if we do another bake, it just uses the previous animation. No need to go through multiple animations. So here we see it takes into account the velocity of the ball and throws the fluid around as if it's attached to the ball, not something falling down from the ball. So it paints the walls because of the velocity. Now let's stop this again. I don't really want that. I just wanted to demonstrate it, so I'm gonna turn it off. And okay, now let's do something more interesting. So I'm going to bring in a plane. Why a plane? So I can get rid of it. Done. We had a geometry node network and we cut off the geometry input because we just need these empty sockets. So what am I going to do? I'm going to fill the actual cube area with obstacles for flip fluids to interact with. Now, how do we do that? Well, we could do this multiple ways as long as you're using a mesh of some sort. It seems to work for now, unless they break something. Let's bring in a line. I ask why? Why a line? That's not a full geometry. It's not going to interact. Well, it's because we're going to instance a cube on it. Now, if we go into point instance, like the cube, we now have two, two squares. We have squares aligned with how many uh, counts there are. Now, I'm not the best at geometry node, so there's not much I could do with this, but there's plenty others can do with it. So here we set our cubes. Want them to be kind of like squarish planes. So we want a point scale. After that, we scale these up. They cover the center. All right. So now we have two cubes to interact with. But well, what's the point of this? Well, I want to now with add a mesh privative cube. What am I gonna do with this cube? I'm gonna add a transform and I'm gonna scale it around the size of the scene. So let's scale this. Now we see cover more or less the scene. We're going to distribute and inst a bunch of cubes Python so we have more over Poison. I don't know how to spell that. All right, and let's also here it's just editing what you want. What we're gonna do is use these cubes as booleans, cut up to cut up the first mesh, the planes. So I want an attribute randomize add scale vector. Now we have a bunch of cubes. Our this another randomize and randomize the rotation. And now we have two planes and a bunch of cubes. What we're gonna do is we're gonna take the Boolean node, put this into our first geometry, and then take our cubes. And your computer, it might tank in performance, like mine will, so get that. And now we have holes in our geometry that can be controlled through geometry node. Now this is possible with mantaflow. It will interact, but it is a little bit finicky, and it's a lot more unstable. Flip fluids seems to just give better results. So we're gonna actually increase the size of our domain a little bit, so we have space. And now, okay, now how do we get this to be an obstacle? Well, simple. We just add it as an obstacle. Done. Now this is an animated mesh, so we don't need to worry about that. already been imported. So now all we need to do is bake. And we skip the animation process because it already knows. And we see the fluid is colliding with the mesh and falling through. Now this, if you wanted this mesh, the obstacle to be animated in the same way, like say it's spinning around, well in that case, you need to add the animation in first, either through a driver or through keyframes, and you need to make sure to export the animated mesh so Flip Fluids knows that it's animated, just like just like the ball is. So here we see goes through the holes, and based on your resolution, it might look weird like this, but it also might give you interesting shapes. For example, this kind of looks like a little cave, start to a cave, so it could be used for a pretty good base mesh for certain projects. So here, uh, multiple uses. Not only that, it just looks interesting. See this, and that's Flip Fluids being used as a collision point. That came out weird. Basically, it's Flip Fluids interacting with geometry nodes. So showing that this is actually, interacting, and it's you're able to change these procedurally. So if you don't like this, you could change it around, add more cues, make it taller, add more planes, and Flip Fluids would respond to it as long as you set it into the appropriate objects. And that's really all. Right now, I'm just talking until more or less done. Uh, but you see, that's really all that it is. Up it here. Really, I want to use this as like possibly concept piece because you just have so many interesting shapes here. You're just like, if looking down here, you see, okay, this could be something. Or you go over here, is like this could be something. Or if you don't like it, you could reset the bake, maybe change some of the seed so you get different looks. Maybe change the period of fluid, or you change the velocity to 5 instead of 1.1, and then bake it again. And yeah, yeah. Bye now.